Welcome back as we continue to study confined spaces. In this section, we will be concentrating on the topic of combustible atmospheres. To fully appreciate a combustible atmosphere, we need first to explain some facts about combustion. The processes of burning and of exploding are both considered to be forms of combustion. In order for combustion to occur, there have to be three elements present in a favorable mixture. The three elements for combustion are fuel, oxygen, and heat or a source of ignition. When these three elements are all in place, then there is combustion. Remove any one of these elements, and combustion cannot occur. When we throw sand onto a fire, we are smothering the flame by preventing the air from getting to it. In effect, we are removing the oxygen. When we pour water onto a flame, we are essentially removing the heat. Fuel can be any substance that will burn, including solids, flammable gases, and flammable vapors. Oxygen, as we know, is always present in a normal atmosphere. When any combustion process takes place, the fuel is combining chemically with the oxygen in the air. Heat is the third element of combustion, and this can also be the source of ignition. Solids normally require a generous amount of heat in order to sustain the combustion process. However, a flammable gas or vapor requires only the heat generated from a spark, as demonstrated here with welding gas, that is to say, oxyacetylene. When flammable gases or vapors exist within the atmosphere of a confined space, the same little spark can set off an explosion. What is the difference between fire and explosion? Technically, both are forms of combustion. A fire is a relatively slow process, and in most cases can be brought under control by removing the heat or by starving it of oxygen. An explosion is a rapid and violent process, and once started cannot be brought under control. This is why flammable gases in an enclosed or confined space are so lethal and frightening. When is the atmosphere in a confined space considered to be flammable or explosive? To answer this question, we need to explain a little basic science. Gases and vapor are basically substances that consist of randomly moving molecules or particles. These particles float around and combine with the molecules and atoms of other gases that constitute an atmosphere, resulting in what is called an air-to-fuel mixture. An air-fuel mixture becomes flammable or explosive when the ratio of oxygen atoms and fuel particles falls into the explosive range. Let us explain. Let us consider, by way of example, the gas methane, which is a common gas in and around sewerage systems. Methane has to constitute at least 5% by volume of the total airspace, and then mixed into the air in order for the atmosphere to become explosive. In this concentration, a source of ignition, such as a spark, would set off an explosion. The 5% mixture of gas is called the lower explosive limit, or the LEL for methane. Any mix below 5% is considered too lean for combustion. Should the proportion reach 15%, then the mixture would be too rich for combustion to occur. This concentration is known as the upper explosive limit, or the UEL for methane. The concentration in between the LEL and the UEL is known as the flammable range. All flammable gases have their own specific LELs and UELs. For example, the gas hydrogen has an LEL of 4% and a UEL of 75 0.6%. Any product or substance that can or will generate flammable vapor will have an LEL and a UEL rating. These details are obtainable off Material Safety Data Sheets, which must be made accessible to the user by the product manufacturer or supplier. It is standard procedure for the atmosphere within a confined space to be tested using specially developed detection and monitoring devices in order to establish whether any vapor is present that could create a flammable atmosphere. Further, should a flammable atmosphere be detected, then the air fuel level or percentage of LEL would also be assessed. Note that this is a requirement of Regulation 5 in the Act, and we shall be looking in more detail at this in the next program. After the break, we shall discuss certain procedures involved in preparation for entry into a space.